similar, not just any kind of figures, similar triangles. So the reason we're talking about triangles is because they are the simplest. There's only 3 sides and 3 angles. And what that means is there's a lot less things to prove that are similar. Okay, if you can prove 2 angles are equal, then you know they're similar. And we'll talk about that in a second. But take a look at this, shadows. This is the biggest thing. When you get the word problems for this lesson, you're going to have shadow problems. It says, legend has it that Thales, the first Greek mathematician, was the first to determine the height of the pyramids. Obviously not by measuring them, but by examining the shadows made by the sun. And I don't know how well you can see it, but there's a tiny little picture of him holding a stick, and he's standing there, and there's a shadow. And then here's the pyramid with the shadow. Okay, so what appears to be true about the corresponding angles? It creates 2 angles. Okay, the height of the stick and the shadow, the height of the pyramid and its shadow, and then the hypotenuse. So what appears to be true about the corresponding angles in the 2 triangles? So what do you think looks like all the angles are what? Well, this is a 90, right? This is hopefully 90. This is probably the same angle as that, and this is the same angle as that. So what appears to be true? They're equal. Because they are. And a right triangle is the one that they like to use the most. Why? Because it's easy to make a right angle. If the corresponding sides are proportional, what could you conclude about the triangles? They're similar, right? Because the definition of similar means that the angles are all congruent and the corresponding sides are all in the same proportion. They all equal the same ratio. So we are going to use that, and just like we did yesterday when we found missing measures of similar triangles, or not yesterday, what would have been Tuesday, right? We had 2 similar figures, and then we used a proportion to calculate the missing sides. We're going to do the same thing with this, and we're going to call it indirect measurement because it's going to give us a way to find lengths that you probably couldn't measure in real life. For example, it's really tough to measure the height of a pyramid because you can't go through the brick right down the center of the pyramid, and you have to kind of go at an angle. Or if something is really, really, really tall, you can't, it's not safe for you to get up there or whatever. So you can use indirect measurement to find those measurements. All right, so I mentioned this already before, but if we have 2 triangles and I can prove that 2 of the angles are equal, so for instance, if we know that angle A is the same as angle F, and we know that angle B is the same as angle G. Well, if we have a triangle and 2 of the angles are equal, what do we automatically know about the third? They have to be equal because they have to add up to 180. And if all 3 angles are equal, then those triangles are similar. That means their sides are going to be in proportion. That is what we use for these when they talk about the shadow, because if I'm standing out next to some flagpole or whatever, and the sun is shining, if I'm at the same time of the day, the sun is hitting both the flagpole and myself at the exact same angle, right? So my height and the height of the flagpole, and then our shadows will be in proportion as long as the flagpole isn't moving, right? It's got to be a 90-degree angle. And I'm standing at a 90-degree angle. All right, so that's what they use there. So if you think about what you know, thank you, about the triangle, if 2 angles are equal, the third one's equal, and then they are proportional. This is what we're going to use down here on slide number 3. First of all, similarity statement. They give it to us. Or we're going to decide that they're similar, and then we're going to write a similarity statement, which is going to be the same as the congruent statement, but just the tilde, no equal sign, just the squiggly sign. All right, similarity statement equals the same as a congruent statement, but we use the similar symbol instead. So determine, are these two triangles similar? They're definitely not congruent because they're not the same size, but are they similar? Take a look at the angles. They gave us the measurements. So 62 and 62, well, those two are equal, right? Now F is 48, but C is 70. Well, they're not equal. But if this is 62 and that's 48, what are those two together? What's 62 plus 48? 62 plus 48 is 110, which means that angle right there is 70 degrees. Wait a minute. Now those two are the same. Any guesses what angle B is? 48. All right, so we know that they are, yes, indeed, similar triangles. So, yes, similar. Now we have to write, did I spell that right? We have to write a similarity statement. So I'm going to start with triangle ABC because, well, it comes first in the alphabet. Triangle ABC, and there's my similar statement, my similar symbol, is similar to triangle. We have to name it in corresponding order. So what angle corresponds with angle A? E, and then with B, F, and then G. Now, that one's pretty easy because they name them both in alphabetical order, but know that they don't always do that, okay? Sometimes they switch it around just to trick you. Okay, so on the bottom, similarity statement is much like a congruent statement. They must be named in corresponding order. All right, let's try another one like this, only with a twist, if you will. It gives me two triangles, and not only, they're kind of touching. They share K, right? We got triangle JKH or whatever, and triangle LMK. And they only give me the measure of one angle in each one. So I know that's 110. I know that's 110. So, are they similar? They didn't give me any side lengths, and they only gave me one angle. Yes, they're similar, Olivia? How do you know that? Okay. Think back to the very beginning when we talked about lines and the angles that lines create. Maybe even if you have your angle foldable. Yes? Yes. This angle right here is equal to that angle right here. Why? What kind of angles are they? They're vertical angles. They're vertical angles. When two lines cross or intersect, opposite angles like these two are congruent. So now I know that this angle is the same as that, and this one is the same as that, which means obviously J and M are the same, and we have similar triangles. So we are going to write our similarity statements. Which one do you guys want to start with? It doesn't matter to me. JKH, you mean? HJ, okay. HJK is similar to triangle. Now, which one does H correspond to? So L better come first, then J corresponds with M, and obviously K corresponds with K, right? How do we know? Vertical angles. That's how we know. Because vertical angles are equal, which means I got two equal angles, and two of them are equal, then all three are equal. Boom. Similar angles. Similar triangles. All right, flip that baby over. Now we use the words indirect measurement. This is probably one of your vocabulary terms. Indirect measurement, one of the most famous is shadow reckoning, and that's what we talked about in that very first example with the pyramids, where we make two similar triangles. So right here with the city backdrop, we have a light pole and we have a tiny little fire hydrant. Do you guys see that? And if I were to take and draw a line from the top of the light pole to the edge of its shadow, and the top of the fire hydrant to the edge of its shadow. Now, hopefully, the construction is good and both the light and the fire hydrant are perpendicular to the ground, so they're not leaning, falling over, right? What happens is we have two similar right triangles, because that angle is the same as that, and then the angle from the sun will be the same, as long as it's the same time of day. Now, you can't go out and measure the shadow at noon and then go back out 4 hours later and measure the shadow of the other one. That doesn't work. You have to measure them at the same exact time, because the sun has to be hitting them at the same angle. Otherwise, it won't work. All right, so a fire hydrant is 2.5 feet high, and it casts a 5-foot shadow. How tall is a street light, which they label for H, that's what we're trying to find, that casts a 26-foot shadow at the same time. Now, here's the part where a lot of kids blow their minds, is the fact that I could set this proportion up about 6 different ways. All right, I could set it up, I'm 6 may be wrong. I know it's at least 4 different ways. All right, so I'm going to give you one way to do it, but know that there's more than one way. But a lot of people sometimes just just tell me what to do. All right, so I'm going to tell you what to do. I'm going to tell you to write 2 ratios. And my ratios, I tend to put shadow over actual height. Shadow over actual height. Because the ratio between its shadow and its height will be the same. So if I start with my light pole, the light pole shadow is 26. The height is H. Then the fire hydrant, the shadow is 5. The height is 2.5. Now, because the ratios are the same, because the sun is hitting it at the same angle, I have a proportion. And if I have a missing measure in a proportion, we can use cross products to solve. So we are going to take 5 times H and 26 times 2.5, which is going to be, help me out, I think it's 65, isn't it? Okay. And what's left? Divide by 5. Or, in other words, the phrase that you probably have heard before, cross multiply and divide. So what is 65 divided by 5? 13. Does that seem like a reasonable height? Oh, it is half of it. Mm-hmm.
Yeah, I just did that. I just did the math in my head.
Okay, so when you're done, that one, they got to start with an easy one, right? So when you're done, always ask yourself, now, does that sound like a reasonable answer? Now, if we'd have gotten like 3.6 for a height, I'm hoping you'd have said, that's probably not right. That doesn't seem like a reasonable height for a light pole, right? So make sure you ask yourself that, and that will help you. Okay, I didn't set it up right. Let me try it again. Any questions on that one? Okay, if you slide over to the next one, example number 3. In this one, they love to give you these questions. And in there, you may not see that there are 2 triangles. So if you don't see 2 triangles, draw 2 triangles. All right? I'm going to show you one triangle is right here. That's one triangle. Do you want me to redraw it down here? Just sketch it. So this is B, D, A. This is 320 meters, and this is 40 meters. Now, where's the other triangle? The whole thing, right? The whole thing makes another triangle. And since They both have a 90-degree angle, and really they share this angle. They're similar. Now this they don't know, that's D. And this is a little bit tricky because what's that distance? What do I have to do with those two numbers? Got to add them together. So what? 482? 482? Now, oh, I forgot this one. Oh, it's 40. I just didn't put it. Now we have three different measures and one missing. Again, lots of different ways I could set this up. Here's what I start with. Oh, I got to find D. I'm going to put it right here. What side in the other triangle corresponds with D? 40. Now I have D on top, so I need to put the other measurement in the same triangle on top. So 482, 2, which corresponds to 320. I have a proportion with one missing measure. How do we solve that? Cross multiply and divide, because 320D equals, what is it, 482 times 40? And then divide by 320? 60.25. What's my label? Meters. Now you can't even hardly see that, but it was can you guys see it a little bit? It was a lake. Right? The distance across a tiny little lake, it's only 60 meters. You could darn near throw a baseball across that lake. You'd have to have a pretty good arm, but you could do it, maybe. Maybe not. It'd be like 180 feet. Yeah. You'd have to have a good arm. All right. Questions on that one? Do we understand how I took those two triangles out? Because I guarantee you will see problems like that again. Okay? Then sometimes they'll give you questions like slide number 7 and not even give you a picture. Draw them. Draw the picture. We got a sign, a street sign, that has a shadow, and a telephone pole that has a shadow. My guess is the telephone pole's higher. What do you guys think? So I'm going to draw a picture. I got a telephone pole. And it has we don't know how high it is, right? That's what we're trying to find. But we do know that its shadow is 12.3 meters. That's the telephone pole. Then we got this sign. And the sign is 2 meters high, and its shadow is 3 meters. Now we can set up our proportion. You don't have to, but I'd like to start with my missing one in the top of my first ratio. So H corresponds to the height of the sign, which would be 2. And then the length of its shadow for H, because I have to put that on top, 12.3, corresponds to 3. So I have 3H equals 24.6. Yes, I did that in my head because I can take 12.3 times 2. Divide by 3, what do we get? I'm pretty sure it's 8.2. Does that seem reasonable? 8.2 for the, it's going to be less than 12.3, check, right? So it sounds all right. 8.2 meters. Questions on that one? 2 last questions. We're coming on 20 minutes here. I know it's a lot. Hey, here's one just like that other one. Determine if they're similar. Remember seeing that one on the front side of the sheet? Are they similar? Yeah, why do we know that? Well, this is similar to this, right? And what other angles? The vertical angles. So now we have to write the similarity statement. So WXY triangle is similar to triangle W, because W corresponds to W, right? X corresponds to V, and y corresponds to u. No, my computer fell asleep. There we go. How about number 2? Are those two similar? Well, they're both right triangles. It definitely looks like it might be. If this is a 90-degree angle, what's this angle? 90 plus 35, that's 125, right? So what do we have left?
60.
Pretty sure it's 55 degrees. But this one's 25. Which means that's 65 degrees, right? Are they similar? No, they are not. All right, so your assignment for today is out of the textbook. So I kind of gave you a heads up, tried to tell you to grab it. If you didn't have it, you can. Ivani, I can probably hook you up with some extra. You have plenty of time, so you should be able to get that done.